In the name of Allah, the most beneficent and the most merciful. The first lecture of Zero Chemistry course is Significant Figures. We will learn all important concepts, my personal tricks, and exam questions of significant figures. Now, what are significant figures? Well, in chemistry, we deal with many measurements like length, mass, temperature, and volume. Let's understand this concept with a simple experiment. Suppose we draw a line AB on the board. Now I ask 3 students to measure the length of this line. The first student measured it 9.5 centimeter. The second student measured it as 9.6 centimeter, while the third student measured it as 9.7 centimeter. Now observe carefully that what is happening here. All 3 students agree on 9 centimeter, but they disagree about the next digit. One says 5, one says 6, and one says 7. Now pay very close attention. This tells us something very important. In first measurement, here 9 is 100% sure digit, but 5 is doubtful digit. In second measurement, 9 is again 100% sure digit, but 6 is doubtful digit. In third measurement, 9 is again 100% sure digit, but 7 is doubtful digit. Remember that by 100% sure digit, I mean certain digit, and by doubtful digit, I mean uncertain digit. Let me repeat it. By 100% sure digit, I mean certain digit. By doubtful digit, I mean uncertain digit. So from this example, we define significant figures as a collection of certain digits, and uncertain digit is called significant figures. So in simple language, we learn that significant figures are certain digits, are 100% sure digits, and uncertain digit are doubtful digit. Here, remember this very important point. Significant figures only exist in measurements. They do not exist in exact numbers or well-defined numbers. For example, think about exact numbers. The number of students in a class, say 25 students. The number of apples in a basket, maybe 12 apples. The number of pencils on a desk, like 30 pencils. Or the number of molecules in a chemical formula, like 2 atoms of hydrogen in H2O, or pi number, Avogadro number, Planck's constant, and Boltzmann constant. These are exact numbers, or we say they are well-defined numbers. So we say that they have infinite significant figures, because here every digit is perfectly certain, or they are 100% sure digits. I mean, they have no doubtful digits, so we don't apply significant figures to them. Now I will teach you my personal tricks to count significant figures quickly. The first trick is for decimal numbers. I mean numbers without a decimal point. The rule is very simple. Start from the first non-zero digit and go up to the last non-zero digit. Everything between them is significant. Let me repeat it. First non-zero digit to the last non-zero digit, all are significant. For example, consider these numbers. Now in the number 12809, the first non-zero digit is 1 and the last non-zero digit is 9. I count all the digits between them. There are total 5 digits, so this number has 5 significant figures. Another example is 4062. The first non-zero digit is 4 and the last non-zero digit is 2. I count all the digits between them. There are total 4 digits, so this number has 4 significant figures. Similarly, in the number 7003, there are total 4 digits. So this number has 4 significant figures. In this number 50231, there are total 5 digits. So this number has 5 significant figures. In this number 300468, there are total 6 digits. So this number has 6 significant figures. Thus remember that in case of non-decimal numbers, we go from first non-zero digit to the last non-zero digit. Now the second trick is for decimal numbers. The rule here is slightly different. Start from the first non-zero digit and count till the end of the number. Let me repeat it. First non-zero digit to the last digit of the number, everything counts. For example, consider these numbers. In the first number 3.140, the first non-zero digit is 3. I count till the last digit. There are total 4 digits, so there are 4 significant figures. In the second number 0.00245, first non-zero digit is 2. I count till the last digit. There are total 3 digits, so there are 3 significant figures. In the third number 0.040097, first non-zero digit is 4. I count till the last digit, so there are 5 significant figures. In the fourth number 2.30000, the first non-zero digit is 2. I count till the last digit, so there are 6 significant figures. Thus remember that in case of decimal numbers, we go from first non-zero digit to the last. Now the last trick is for non-decimal numbers ending with 0. For example, consider the number 260000. How many significant figures does it have? Well, the answer is simple. According to the first trick, we go from first non-zero digit to the last non-zero digit. So it has 2 significant figures. But according to me, it is only 20% true, and I will show it to you. Remember that when we express it in scientific notation, its significant figures completely change, because those zeros at the end may or may not be significant. To remove this confusion, we use scientific notation. For example, consider these numbers. Now these numbers have decimal point. We will use the second trick of decimal numbers, which is very simple. Go from first non-zero digit to the last. In first number 2.6 into 10 raised to the power 5, there are 2 significant figures. In the second number 2.60 into 10 raised to the power 5, there are 3 significant figures. In the third number 2.600 into 10 raised to the power 5, there are 5 significant figures. In the fourth number, there are 5 significant figures. In the fifth number, there are 6 significant figures. So this number has different significant figures if we express this number in scientific notation. Thus, by using scientific notation, we remove all ambiguity. This is why scientific notation is very important. To summarize this, we learn that for non-decimal numbers, count from first non-zero digit to the last non-zero digit. For decimal numbers, count from first non-zero digit to the last. For numbers ending with 0, use scientific notation to know the exact significant figures. Remember this carefully. I mean, this is the key to solving questions quickly and easily. Now we will learn rounding off rules for significant figures. The first question is, why we even need to round off? Well, consider that you measure something like this, 16.863247. Now think about it. We need to cut the extra digits in this measurement. I mean, we do not need unnecessary digits. This cutting process of unnecessary digits is called rounding off. By rounding off, I mean keeping only those digits that your measurement actually supports. If my instrument supports 3 digits, I will keep 3 digits. And if my instrument supports 4 digits, I will keep 4 digits. I will remove all those extra digits, and this process is exactly known as rounding off. The first situation is the easiest one. If the digit after last significant figure is less than 5, I mean it is 0, 1, 2, 3 or 4, you simply drop it. For example, consider the number 4.732 and we want 3 significant figures. Our 3 significant figures are 4, 7 and 3. Here, the last significant figure is 3 and the digit after this significant figure is 2. I will cut off this 2 because it is unnecessary digit. Since 2 is less than 5, we just drop it. So the answer becomes 4.73. Nothing changed and nothing moved. Now consider another example. 8.641 rounded to 3 significant figures. The 3 digits are 8, 6 and 4. The next digit is 1. I mean, we do not need this 1. Since 1 is less than 5, we drop it. We get 8.64. Nothing changed and nothing moved. Now the second situation is, if that digit after last significant figure is greater than 5, I mean, if it is 6, 7, 8 or 9, we increase the last significant digit by 1. For example, consider 5.678 and we want 3 significant figures. The digits are 5, 6 and 7. The next digit is 8. I don't need this 8. Since 8 is greater than 5, the 7 becomes 8. So the answer is 5.68. Now consider another example. 2.946 rounded to 3 significant figures. The significant figures are 2, 9 and 4. The next digit is 6. Since 6 is greater than 5, the 4 becomes 5. We get 2.95. Thus remember these 2 important basic rules. Now we will learn odd-even rule, which is very important. I always ask this important question. What happens when the digit after last significant figure is exactly 5 and nothing else? This is the biggest exam trap. Most students see a 5 and immediately round up every single time. But this is not always correct according to some syllabus like NCERT. So listen carefully because there are 2 situations here. Here is the rule. If that digit is even, do nothing, leave it exactly as it is. If that digit is odd, increase it by 1. For example, consider 2.35 rounded to 2 significant figures. Here, the last digit is 5. Step back from the 5. The digit before it is 3. Is 3 even or odd? It is odd. So we increase it by 1. I mean 3 becomes 4. So the final answer is 2.4. Now consider 2.45 rounded to 2 significant figures. Step back from the 5. The digit before it is 4. Is 4 even or odd? It is even. So we do nothing. I mean 4 stays as 4. So the final answer is 2.4. Thus remember these 2 lines. If digit before 5 is odd, go up by 1. If digit before 5 is even, stay where you are. Now that you understand rounding rules, let us move to calculations. Because this is where students make the most expensive marks. There are 2 types of calculation and each one has a completely different rule. Addition and subtraction use one rule, multiplication and division use a different rule. You cannot mix them. Let me explain both. In addition and subtraction, we count decimal places. By decimal places, I mean the digits that appear after the decimal point. The rule is that your final answer must have the same number of decimal places as the number with the least decimal places. For example, consider 12.3 plus 4.56. Now here 12.3 has one decimal place. I mean there is only one digit after a decimal point. And in 4.56 there are two decimal places. I mean there are two digits present after decimal point. So our answer must have only one decimal place. We calculate 12.3 plus 4.56, which gives us 16.86. But we need only one decimal place. I mean, we need only one digit after decimal place. So we look at the second decimal digit, which is 6. Since 6 is greater than 5, we round up. So the final answer is 16.9. Now let's try one with subtraction. 7.45 minus 2.1. Here 7.45 has two decimal places and 2.1 has 1. The digits that appear after decimal place is 1. So the answer needs one decimal place. We calculate 7.45 minus 2.1, which gives 5.35. The next digit after last significant figure is 5 with nothing after 8. The digit before 5 is 3, which is odd. So we round up. Thus the final answer is 5.4. Now in multiplication and division, the rule is completely different, and this is where students lose the most marks, because they apply the decimal place rule here too. Do not do that. In multiplication and division, we forget decimal places completely. Instead, we count significant figures. The final answer must have the same number of significant figures as the number with the least significant figures. For example, consider 2.5 multiplied by 3.42. Now 2.5 has two significant figures and 3.42 has 3. The least significant figures are 2. So our answer needs two significant figures. We multiply and get 8.55. The next digit after last significant figure is 5 with nothing after 8. The digit before 5 is 5, which is odd. So we round up. Thus the final answer is 8.6. The second example is 4.52 divided by 1. Here 4.52 has 3 significant figures and 2.1 has 2. The least significant figures are 2. So the answer needs 2 significant figures. After calculation, I get 2.152. Now the digit after the first 2 significant figures is 5, followed by 2. 2 is less than 5. I drop it. So the final answer is 2.2. Thus remember that addition and subtraction go by decimal places, multiplication and division go by significant figures. Finally, we will learn some important questions of significant figures. We start with question number 1. Here, it is asking us to count the significant figures in each number. Let's go through them one by one using our 3 tricks. The first number is 0.0025. Now look at this number. It has a decimal point, so we use trick number 2. Trick number 2 says, find the first non-zero digit and count from there till the very last digit. The first non-zero digit is 2. Now count from 2 till the end. We have 2 and 5. That is 2 significant figures. The second number is 208. This number has no decimal point. So we use trick number 1. Trick number 1 says, find the first non-zero digit and go up to the last non-zero digit. Count everything between them. The first non-zero digit is 2 and the last non-zero digit is 8. Count everything. 208. That is 3 significant figures. The third number is 2.300. This number has a decimal point. So we use trick 2. Find the first non-zero digit and count till the very last digit. The first non-zero digit is 2. Count from 2 till the end. 2300. That is 4 significant figures. The fourth number is 1005. No decimal point. So we use trick number 1. The first non-zero digit is 1. The last non-zero digit is 5. Count everything between them. 1005. That is 4 significant figures. The fifth number is 0.05060. Decimal point is present. So we use trick number 2. The first non-zero digit is 5. Count from 5 till the end. 5060. That is 4 significant figures. The sixth number is 5.020 times 10 squared. This is already in scientific notation. So we ignore the power of 10 completely. We only look at 5.020. It has a decimal point. So we use trick number 2. First non-zero digit is 5. Count till the end. 5020. That is 4 significant figures. The seventh number is 6 times 10 cube. Again ignore the power of 10. Look at 6.0 only. Decimal point is present. We use trick number 2. I mean the first non-zero digit is 6 and count till the end. 6 and 0. That is 2 significant figures. So this was all about the first question. Now let's consider question number 2. Here it wants us to first write each number in scientific notation and then state the significant figures. Here we can see that some of these numbers end with zeros and have no decimal point. These are exactly the numbers where we use trick number 3. Now in case of first number, which is 56000, this is a non-decimal number ending with 0. We already learned that we can write this number in different ways. So I convert it to scientific notation first. I move the decimal point to just after the first digit. That gives us 5.6 times 10 raised to the power 4. Now this number has a decimal point, so we apply trick number 2. First non-zero digit is 5. Count till the end. 5, 6. That is 2 significant figures. The second number is 0.0078. This has a decimal point. The first non-zero digit is 7. We move the decimal to just before 7. We write this number in scientific notation, which gives us 7.8 times 10 raised to the power negative 4. Now count significant figures using trick number 2. The significant figures are 7 and 8. Thus it has 2 significant figures. The third number is 450000. It is a non-decimal number ending with 0. I write it in scientific notation. 4.5 times 10 raised to the power 5. Now I use second trick. The first non-zero digit is 4 and count till the end. 4, 5. That is 2 significant figures. Hence note it down this second question. Now let's consider question number 3. Here we need to round off each number to 3 significant figures. To find 3 significant figures in each number, we will first use tricks to identify them. Then we will look at the next digit and apply the rounding rule. The first number is 34.216. Decimal point is present. We use trick number 2. The first non-zero digit is 3 and count till the end. Our three significant figures are 3, 4 and 2. The next digit is 1. Since 1 is less than 5, we drop it. So the answer is 34.2. The second number is 0.023456. Decimal point is present. We use the second trick. The first non-zero digit is 2 and counting till the end. Our three significant figures are 2, 3 and 4. The next digit is 5 and there is a 6 sitting after that. Since 5 is followed by a non-zero digit, we round up. So 4 becomes 5. Thus the answer is 0.0235. The third number is 7.8951. Decimal point is present. We use trick number 2. First non-zero is 7. Our three significant figures are 7, 8 and 9. The next digit is 5 and there is a 1 after 8. Since 5 is followed by a non-zero digit, we round up. So 9 becomes tens. But listen carefully. We cannot write 10 in one digit, so we carry over. The 9 becomes 0 and the 8 becomes 9. So the answer is 7.90 and that 0 at the end is written on purpose. It is our third significant figure. The fourth number is 0.09876. Decimal point is present. We use trick number 2. First non-zero digit is 9. Our three significant figures are 9, 8 and 7. The next digit is 6. Since 6 is greater than 5, we round up. So 7 becomes 8. So the answer is 0.00988. Hence noted down this third important question. Now consider question number 4. Same process, but this time we round to 4 significant figures. The first number is 12.3562. Decimal point is present. We use trick number 2. First non-zero is 1. 4 significant figures are 1, 2, 3 and 5. The next digit is 6. Since 6 is greater than 5, we round up. So 5 becomes 6. Thus the answer is 12.36. The second number is 0.0045789. Decimal point is present. We use trick number 2. First non-zero is 4. 4 significant figures are 4, 5, 7 and 8. The next digit is 9. Since 9 is greater than 5, we round up. So 8 becomes 9. Thus the answer is 0.004579. The third number is 8.76543. Decimal point is present. We use trick number 2. First non-zero is 8. 4 significant figures are 8765. The next digit is 4. Since 4 is less than 5, we drop it. Then 5 stays unchanged. So the answer is 8.765. Thus noted down this fourth question. Now consider the final question. This is where students lose the most marks. We need to perform calculation and apply the correct rules. Remember that addition and subtraction go by decimal places, while multiplication and division go by significant figures. Let's go through each part. The first part is 12.4 plus 3.76 plus 0.009. This is addition, so we count decimal places. 12.4 has 1 decimal place, 3.76 has 2 decimal places, while 0.009 has 3 decimal places. The least decimal place is 1, so our final answer must have only 1 decimal place. We add all of them. 12.4 plus 3.76 plus 0.009, which gives us 16.169. Now we round to 1 decimal place. The next digit is 6. Since 6 is greater than 5, we round up. So the final answer is 16.2. The second part is 7.235 minus 2.1. This is subtraction, so we count decimal places. 7.235 has 3 decimal places. 2.1 has 1 decimal place. The least decimal place is 1, so our final answer needs 1 decimal place. We subtract 7.235 minus 2.1 gives us 5.135. The next digit is 3. Since 3 is less than 5, we drop it. So the final answer is 5.1. The third part is 4.56 multiplied by 1.4. This is multiplication, so we count significant figures. In case of 4.56, there are 3 significant figures. In case of 1.54, there are 2 significant figures. The least significant figures are 2, so the answer needs 2 significant figures. We multiply 4.56 times 1.4 gives us 6.384. Our 2 significant figures are 6 and 3. The next digit is 8. Since 8 is greater than 5, we round up, so 3 becomes 4. So the final answer is 6.4. The fourth part is 8.64 divided by 3.2. This is division, so we count significant figures. In case of 8.64, there are 3 significant figures. In case of 3.2, there are 2 significant figures. The least significant figures are 2, so the answer needs 2 significant figures. We divide 8.64 divided by 3.2, which gives us 2.7. That's already 2 significant figures. So the final answer is 2.7. Thus this was all about significant figures. And the next lecture, we will learn each and everything about mole concept.